All right, so today's lesson is on nonlinear systems of equations. So the definition here is two or more equations at least one of which is not linear. So what we're looking at today, we're not dealing with any more than two equations in Algebra 1. But we'll be looking at two equations, and sometimes one of them will be linear, but never both of them will be linear. So just kind of different combinations here. This is linear and quadratic on this first page, and then it switches on the next page. The solution set to a system of equations is the set of points in which the equations intersect. We actually did this earlier this year, but only with linear equations. There can be one solution, so it's possible for these to just intersect in one spot, multiple solutions, or no solution. So one solution, we're just showing you a few ways that the graph could look for that to happen. So here we have a parabola and a linear equation. They just intersect at this one point. Or you could have two parabolas, two quadratic equations just intersecting at one point. Multiple solutions, we're just showing there's two intersections here as well. No solution, they just don't cross each other at all. So we see a separate parabola and line here, a quadratic and a linear. We also see two separate parabolas. So what we're doing is we're solving by graphing, which will rely on some skills that will really be helpful for you to practice like before the exam. So this first equation here is a linear equation. It looks like y equals mx plus b. So it's actually all ready to graph. So I'm just kind of labeling that it's linear. The y-intercept of that equation is this -1 here, because that's your b value. So it crosses the y-axis at -1. And then the slope is -2. So from there it goes down 2 over 1. So I'm just kind of going in both directions just to get a good picture of this line. The next equation here is a quadratic equation. So in a quadratic equation, remember we have an x squared. This one happens to be in standard form. I'm just kind of labeling that it's quadratic, although it does tell us that off to the side here. So I guess I don't need to label that because it tells us right here, this first set is linear and quadratic. So to graph this quadratic equation in standard form, we want to find the vertex and put it like in the middle of our table. So find the vertex. We always use x equals -b over 2a. I was just trying to give myself a little bit more room here. So -b over 2a in this case would be +6 over 2 times 1, which is 3. 6 divided by 2 is 3. So now I'm going to make my table. It needs 5 spots. I'm just kind of making. The middle x value is 3. You don't really need to make a perfect table, but 3. And then we're going to plug 3 in for x. You can use the calculator to do that or do it in your head. You're going to get 9 minus 18 is -9 plus 3 is -6. All right, fill in the rest of your table. Remember, as far as the table goes, these two spots are going to be the same. The yellow ones, I'll call them. Those will be the same because of the symmetry around the vertex. And these two green ones are going to be the same. So for the yellow, we can either plug in 1 or 4. Plugging in 1 is easier for sure. So we'll plug in 1 into the quadratic equation, so the second one here. You can use a calculator or do it in your head. 1 minus 6 is -5 plus 3 is -2. Means this is also -2. Then plug in 2 or 4. I'm going to plug in 2. 4 minus 12 is -8 plus 3 is -5. All right, let's graph that quadratic. 1, -2 is right here. 2, -5, 1, 2, 3, 4, 5. That's already one of our solutions. I can tell they intersect there. 3, -6. 1, 2, 3, 4, 5, 6. 4, -5. And then 5, -2. So graph your quadratic. It looks like this is a situation where we have one intersection point. I'm going to highlight it here. They intersect right here, which is at 2, -5. So I'm going to write the solution right there. Just one solution to this system of equations. All right, this next one is another quadratic function and a linear function. So for this quadratic function, is actually the first one here. So we're going to approach that much like we did on the last problem. So let's do -b over 2a again. -b over 2a will give us the x value of the vertex. -b is actually +4 over 2 times -1. 4 divided by -2 is -2. So that's going to go in the middle of our table. Remember, we need 5 spots. -2 is the middle one. Plug that in. Remember, when you plug that in, you want to leave that negative outside of the parentheses. So it's going to look like this. You're going to get negative, that's going to be 4 plus 8 is 4 plus 3 is 7. All right, fill in the rest of your table. Right, again, these green spots are going to match exactly like the last time because of the symmetry. And then these yellow spots will match as well. So the yellow ones, I can plug in 0 pretty easily without doing any work on my calculator. When I plug 0 into the quadratic, I'm just going to get the constant term, which is 3. So those are both 3. Then I can either plug in -3 or -1. I'm going to plug in -1 for x. So plugging that in or typing it in the calculator, we're going to get -1 plus 4 is 3 plus 3. We should get 6. Graph that quadratic. -4, +3. -3, 6. -2, 7. -1, 6. 0, 3. There's my quadratic. All right, then I'm going to graph the linear function. The linear function is this bottom one, but it's not in y equals mx plus b. So we have to solve it. So I'm going to move the x by subtracting it. It's still not solved for y though, so we want to multiply both sides by -1. I'm just putting times -1. So I get y equals +x plus 7. So the y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. And the slope is +1. Just plotting kind of a lot of points because I want to see the intersections. So here we can see we have 2 intersection points. They are right here at, I'll figure out the coordinates of that in a second, and then right there. So it looks like -1, 1, 2, 3, 4, 5. I think it's -1, 6 is one of my intersection points. And then my other intersection point is right here, which is -4, 3. So 2 intersection points. Obviously, these problems kind of take quite a bit of work. So you're not going to have like a ton of them on the homework. Okay, moving on to this next page. Here they're showing us we have 2 quadratic equations. So if you have 2 quadratic equations, if they're in standard form like they are in number 3, you're going to need to make 2 tables to graph them. So you would do the same thing we did on this page, and we've done, many times with graphing quadratics. You would just make 2 tables and find the intersections. The thing is, if we were to actually do this one, these parabolas don't end up crossing each other, so there ends up being no solution. So if you happen to work ahead of me, this one actually has no solution, but you wouldn't really be able to tell that until you graphed them both, since we're using graphing to solve it. But I'm actually going to skip number 3, and I'm going to do number 4. So number 4, that first quadratic is in standard form, but it's actually probably easier if we just kind of think about that being like this. So therefore your vertex is 0, 4. And you don't need to do negative b over 2a. But if you do negative b over 2a, the b value is 0, so you're going to get the same thing. So I'm going to do the chart for this one in blue. So x, y, the middle spot 1. The middle one is 0, 4. Okay, I can either plug in, keeping in mind the symmetry of this chart. These green ones will match again, and the yellow ones will match. So for the yellows, I can either plug in negative 2 or positive 2. Let's plug in positive 2. So plug positive 2 in the equation. We have negative 2 squared plus 4. Negative, it's going to end up being 0. For the greens, I can plug in negative 1 or positive 1. Plug it in positive 1. You're going to get negative 1 plus 4. You're going to get 3. All right, then you need to make a table for the second quadratic equation. So again, the vertex is going to need to go in the middle. So I'm actually going to graph this quadratic, so I have it on here. Okay. And then I'm going to use some of the space over here. I think I need to kind of erase this part a little bit so that I have some space to graph the second one. And I'm going to graph the second one in red. So I'll do negative b over 2a would be positive 4 over 2 times 1. 4 over 2 is 2. So when we make our chart, we will put 2 in the middle. Notice there's not a lot of room on here. We're going to plug in 2. 1, 0, 3, 4. All right, once again, these yellow spots will match, and the green spots will match. And we still need to plug in 2. So let's see, I'm going to go in a different order this time, I guess. For plugging in 0, I know I'm just going to get my constant term, so that's negative 2. So this is going to be negative 2. This is also going to be negative 2. For the green spot, I can plug in 1 or 3. I'm going to plug in 1, and I'm going to use this space up here, actually, in this number 3 spot, to plug in. I'm plugging in 1 into this red equation. 1 minus 4 is negative 3 minus 2. You should get negative 5 when you plug in 1. So this is also going to give you negative 5. Then plug in 2, because I still haven't found the y value of the vertex. Plug in 2. 4 minus 8 is negative 4 minus 2 is negative 6. Okay, graph your points. 0, negative 2 is right here. 1, negative 5. 2, negative 6. 3, negative 5. 4, negative 2. Connect. Okay, and this is where it's an example of why sometimes when you're doing these by hand, it's a little bit hard to tell where they intersect. I think, let's see, I'm trying to find the intersection between the red and the blue. So if I zoom in, like right about here, I think that looks like 3, negative 5. So I'm going to go with 3, negative 5 for that one. We could tell if we plugged them into the original. But this won't always be 100% accurate. Now this one, to me, it looks like negative 2, positive 2, but that's actually not right. If you look at the answer key, they're supposed to intersect at negative 1, positive 3. So I'm going to put that, although it just really doesn't look like that on my graph. So I must not have done a great job drawing that parabola, which does happen sometimes when you're solving by graphing. It's not the most accurate way of solving. All right, moving on to our final set here. These are linear exponential and quadratic exponential. So kind of just reviewing the whole exponential graph thing, which is great because those are on your exam. So this first one here is an exponential function. I'm just going to kind of rewrite it and then point to it. So this is exponential growth because the base of the exponent is 3/2, and that's bigger than 1, which makes it growth. The y-intercept is the first value that I see. So the y-intercept of this is 4. So make it cross the y-axis at 4. 1, 2, 3, 4. Then we're multiplying by 3/2. So to go to the right on this graph, which is all we're doing, you're just taking your y-intercept and you're multiplying by 3/2. 3/2 is 1.5, so that if that helps, just take 4 times 1.5 on the calculator or in your head, you should get 6. 6 times 1.5 is 9. So 9 times 1.5 is going to be 13.5, which is going to be right about here. And that times 1.5 is going to be too big to fit on the graph. So there's my exponential graph. Ooh, I did not do a great job connecting the dots, which just means it's not going to be super accurate, which we saw in our last one. This is a linear function. You could use intercepts to graph it if you remember how to do that, or solve it for y. I'm going to solve it for y, so it looks like y equals mx plus b. You get y equals -1/2 x plus 10. That hopefully is something that you're pretty good at doing rather like quickly, because you will be like doing that again in geometry. So go to 10 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's your y-intercept. Go down 1/2. Okay, I can already see the intersection actually. So I don't need to worry about going too much further because I can kind of already tell where they intersect. They just have that one intersection. I'll circle what I'm talking about right here. I believe it's 2, 9. Yep, looks like it's 2, 9. So just one solution here. Then on this final one, it is a combination one where we have a quadratic equation and we have an exponential. I'm actually going to do let's do the quadratic first. We'll just go in order. That quadratic equation is in standard form. So again, we're going to do -b/2a. Hopefully all of this graphing is helping those of you that want to retake that test still, the quadratic test. So -b is +8 over 2 times -1. I think some of you are just trying to type that in the calculator as is, and that's not going to work. You have to think about the fact that's 8 over -2, which is -4. So you're going to put -4 in the middle of your table. -4. Plug a -4 in. I do not have a ton of room. I'm going to use this space over here to the left of the function to plug values in. So we have -4 squared. We'll plug in -4 for x. -8 times -4, -7. Type that in the calculator if you want. You're going to get -16 plus 32, which is 16. -7 is 9. All right. Fill in the rest of your, I almost put -3, that's wrong. Fill in the rest of your chart. So we're going to do -5, -6. This is -3, -2. Okay. I feel like I've done this a bunch of times today, but so for this next part on here, you are plugging in either -3 or -5. Those greens will match. And then for the yellow, you're plugging in -2 or -6. All right, I'm going to plug in -3 over to the left. So you get -3 squared -8, -3, -7. Type that in the calculator if you want. -9 plus 24, 15 -7, which is 8. So these are both 8 for the green spots. -2 and 6, let's plug in -2. -4 plus 16, which is 12 -7, which is 5. All right, graph that quadratic. -6, 5. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Did I count right? 1, 2, 3, 4. Okay. -5, 8. -4, 9. -3, 8. -2, 5. There's my quadratic. All right, now graph the linear function. Or no, it's not linear. It is exponential. So this exponential function has a y-intercept of 18. So we'll go to 18 on the y-axis. Oh boy, how high does this go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like it's right there. Then it's exponential decay, so we're multiplying by 1/3 to go to the right. So multiply by 1/3. 18 times 1/3 is 6. 1, 2, 3, 4, 5, 6. Those are not going to intersect. 6 times 1/3 is 2, etc. 2 times 1/3 is 2/3. Okay, so the red and the blue graphs are never going to intersect. So after all that work, this one actually has no solution. So, and sometimes that does happen. So it looks like your homework, we are solving some of them. The sub is going to pass out your homework now, and you can work on that for the rest of class today. I want you to like show all of your work on this, just like I did when I was going through the notes with you. And then you only have to do the odd questions because I feel like it does involve some work. If you do the evens as well, there'll be a little bit of extra credit. So your homework on this is odds only. If you do the evens, there's a little bit of extra credit. Okay, tomorrow I will see you. Tomorrow is when you're going to get back your Unit 8 tests. So if you want to retake that, you're going to have to start working on your test corrections. I would also suggest you maybe look at the study guide again. The retake, like by default, if you don't arrange another time with me, it's going to happen on Monday during class next week. There are a couple other options, but Monday is probably the soonest one. So just make sure you talk to me if you haven't already. I will see you tomorrow, and enjoy the rest of your day.